Thank you for coming. And today I'd like to talk about serverless. It's the way microservices should be. You probably have heard for the serverless buzzword, but let's see what the serverless is, how to use it, and what are the pros and cons here. Before that, I'd like to start with a simple thing called scaling. It's actually not so simple. Nowadays, everyone is talking about scaling. Everyone wants to auto-scale their apps. They want to have millions of users. They want their apps to work in any situation. Even when you go to Google or Facebook interviews, they will ask you if you know something about scaling, if you know how to write a fast function that can scale easily. And it's a really popular thing. And people are wasting a lot of time on scaling. And today I'd like to show you a simple way to go with scaling. So how many of you here are trying to scale your app and make it faster and easily have more users on your app? Yeah, can I see some hands? Yeah. Nice. So a lot of you. So how many DevOps engineers you have in your team that are working with you on scaling your application? If you think that you have more than you should, yeah, please put your hand, yeah. Okay, nice. So how many DevOps do you really need now? I think that the number is 0. So, and today I want to show you how to achieve the 0 DevOps environment. So I'm Ivan. I work as a senior software engineer at Nearform. We are based in Ireland, but most of the people work remotely, as I do, since I live in Belgrade, in Serbia. We do stuff with JavaScript. We are maintaining Node.js, a bunch of other modules. I have a bunch of Nearform stickers here, so if you want, just find me later. And you can find me on Twitter and on my blog, where I write about stuff that I like, usually JavaScript. So let's move on. How did we get here? We first had Monolith, so it's a simple Node.js app, just one instance, and it was fine. After that, we started with microservices. So we started with decoupling our apps into smaller services that work together. And now we want to talk about serverless, so something new, something probably more better. So the monolith part. Let's see some pros of the monolith architecture. So first thing, it's a setup. The setup is usually simple, in that just one app. You just run some framework, and you can deploy that, and that's it. You have your app. Next thing, it's one app to maintain. So it should be easy. You have just one code base. Code is at one place. Deployment, again, should be easy, since just one deployment script is needed, just one server, and you're ready to go. Then you have shared memory between functionalities, which means that you can just import some function from other file and run it. You don't need to have any connection with that. And monitoring and logging is really simple. As I said, just one application, so just connect your application with some logging and monitoring system. You will have everything there. And adding new functionalities is also really simple. Just create a new file in your repo, and you have a new functionality. So some cons with monolith architecture are extending app without breaking some other things. When your app becomes really big, and if you don't have a lot of tests there, it's so hard to add a new functionality and be sure that you didn't break something else. Then slow delivery and deployment. When your app grows up, a lot of connection is happening there, and you need to do a lot of things to make a new feature. And also the deployments become really slow, since the build time is bigger and bigger. So if you have one bug fix, you probably need to wait a couple hours for your build to finish and to be deployed on the server. And then a large code base to maintain. Everything is at one place. A lot of people working on that thing. It becomes hard to maintain it. And sometimes it's hard to understand when you onboard a new developer in the team. he will just see a bunch of code. He will try to search there, but he will definitely have problems. And as it evolves, the development time is increasing. That's something about Monolith. Let's see the microservices and why we migrated from the Monolith concept to microservices. So here we have some pros. In microservice architecture, we want to decouple everything. So we have smaller services that are independent, they are deployed independently, they can work independently, but when you connect them, they work as one app. Then you have async communication between services, so that means that services are loosely coupled. They don't depend on each other. If one service goes down, then the whole app will still work. Some features will be missing, but your app will still be there. Then you have independent deployment. And microservices should be easier to understand. If you have good documentation, then you can document all your services, what they do, and when someone wants to change something, he can just find that in documentation, open the code for that service, he can fix it, and redeploy it again. Speeds up development. So as I said, you have smaller apps, they are easier to develop. And it really enables continuous delivery and deployment. So immediately when some service is added, fixed, updated, you just put that on your continuous integration or continuous delivery service, and that will be deployed. So just that service without touching anything else. So there should be some cons. It's not that ideal. First thing is setup. So if you're starting with a microservice architecture, you first need to have a lot of applications. You need to have some system that will allow you to exchange information between your services. You will need to use Docker, Kubernetes, something for orchestration, for containers. So a lot of things there, and you will really spend a lot of time to set up everything. Then service discovery. You will have your services as an apps, but how to tell other services that new service exists. You need to find some ways to do that too. Then monitoring. You will have probably a bunch of charts to look at for every service. When some error happens, it might be harder to find it. So error tracking can be problematic sometimes. Same thing for logging. Probably your all services will log at one place, and your logs will be really big. So searching for issues will be hard sometimes. And how we do microservices now? So this is why the setup is hard sometimes. You will have your Node.js services, hundreds of them. Then you will use Docker to create packages and to make containers of your services with all the code and all dependencies there. And you will need Kubernetes to then scale your services to basically tell which services you want to run, how many of them, which is also a new thing that you need to learn. And for communication, you then need to use something like Kafka. That's a messaging system made by LinkedIn. Now it's open source. It's really fast, but you also need to set up the Kafka. You need to create partitions, other things inside Kafka. Which is good, but if you don't want to spend that much time on operations, this will take you a lot of time, and it will be a problem for you. So how can we fix this? Here is Serverless. It's coming to the rescue, and let's talk more about that. So what is Serverless exactly? And I have a simple definition here, and it should explain everything about Serverless. It's a cloud computing execution model in which the cloud provider is dynamically managing allocation of the machine resources. So the cloud provider is usually Amazon, Google, and you dynamically get the memory, and processor power that you need. You don't need to set up anything. And how that looks, so here we have a computer sending some request to our service provider, to a big server, and it magically just starts adding more instances that are required to process some requests from this client. Then those informations will go back to the client, and then the service provider will just close the instances that are not used anymore. So here is this is simply how it works inside your Lambda functions, how we call them. You will just put your code and leave that to the service provider to scale it to add as much as you need. So some pros. Setup is really simple. So the good thing with serverless is that you don't need to provision anything. So you just need to write your code, and the service provider will take care of everything. So packaging and deployment is really simple. With some modules, you just need one command line to deploy your service. Cost is small. Yeah, the serverless is really cheap. You, for example, Amazon is giving you a million requests for free, and every second million is, I think, 2 cents or something like that. So that's really cost effective. I know that some companies are having millions of users, and they're spending like $100 for their whole infrastructure that's running on serverless. It should reduce the complexity. So you won't need to add any code to communicate with the other services that will be there. So you will just need to focus on the business logic that's inside your Lambdas. And automatic scaling. So as I said, if you run some Lambda on Amazon, for example, you send a million requests. Million requests will be processed. Amazon will run instances for you, and the results will be returned back to every client. So some cons here. So not ideal, of course. Vendor lock-in. So as I said, there are some service providers, and when you write code for their platforms, you are basically locked down, since the migration from one provider to another is hard. It's different than having Docker and Kubernetes. You can run that everywhere. It's the same thing. But the vendor lock-in is not always lock-in. You have some systems where you can migrate from one provider to another. There's no guarantee that functions will always work. So there is no, you won't get any paper from a service provider that guarantees you that you will have 100% uptime. So that's bad for enterprise when your client requests you to sign some paper to confirm that you will always be up. And for the first requests, there's a thing called cold time. So sometimes it will take some time to run the first instances of the Lambda functions. And yeah, so I said that we don't need DevOps. So let's see how and why. Basically, you don't need to write any setup code. So no containers, no nothing there. The deployment is simple. As I said, I will speak more about some tools that we can use for deployment. So you will see how simple it is to do the deployments. No need to write any big deployment scripts. So functions are so small, and then for scaling, you probably won't have that big functions. So there won't be space for mistakes comparing to the writing some Monolith or microservice apps where you will have a bunch of files in one service, and then you can make some mistakes there and make your app slower. With serverless, your whole services will be probably 1 or 2 files with some dependencies, so there's no space for big mistakes. And yeah, it really doesn't kill the DevOps, it just takes it to the next level. So instead of writing bunch of scripts for deployment for setup from infrastructure, you will focus more on how to speed up maybe your code, how to write, how to better decouple your stuff. So it's a new level of the operations and development. So I said that we have some service providers for serverless. The first one, the most popular, is, I think that they also started first with this. It's Amazon Lambda. AWS has a service called Amazon Lambda. And that's a place where you get a million requests for free, so you can play with it. Then Google Cloud Functions, also a good provider. And we have that on Azure. So those are three most popular service providers. There are also some ways to host your own instances for serverless. Basically, just take any server, install some app on it, and it will allow you to have auto-scaling, but not that good as the serverless providers. So if we want to compare them, and on internet, you have a bunch of comparing between those three. So which one is faster, which one is cheaper. So today, I don't want to make fight between them. Let's just make love. So I will leave that to you. So on internet, you can just find all the informations that you need. And at the end, just use any of those. They're probably good enough for all your use cases. So the serverless architecture, let's see how can we really use serverless to create and deploy our apps. So first thing, yeah, who loves hamburgers here? Can I see hands? Oh, a couple guys. Oh, nice. So better than one hamburger is two of them, or probably even more. And if you want, for example, to have a hamburger with more meat or more cheese, that will cost you money. And the more hamburgers you add, it will cost you more and more. So if we compare hamburger to our app, which also has some layers, it has different things inside, and you start adding more of them and even more, that will still be free. So you will have a really cheap solution there, and it will also auto-scale, also for free, so which is an amazing thing. And in the serverless architecture, so we will have some functions and some services, and you need to have some communications between them. So as in a regular microservice architecture, we have two ways. We have synchronized and asynchronized. So with synchronized, it's just using HTTP or some internal protocol inside the service provider. And it's not really loosely coupled, since your services will depend on each other. And if some error happens, for example, in one service, you made some typo or something like that, then your whole request will go down. With the synchronized, this is the logo of the AWS SNS service, so simple notification service, which is just messaging service. Whatever message you put inside, you have a publisher that's sending a message, and listeners that will just subscribe to SNS and will wait for some messages to come there. And that's, I think, a better solution, since the serverless functions are event-driven functions. So if you want to use HTTP, you need to use one more method for handling those HTTP requests, one more service for handling those HTTP requests, and then sending async event to the serverless function. With asynchronous, you immediately have that. So one function will just send a message to SNS, and other one will take it, and in that way they can communicate together. If some service goes down or you have some error inside, then your message will be kept on SNS. When you update your code for that service, they will just be processed, so you won't lose anything. So synchronize works like this. You need to have Amazon API Gateway that will handle the HTTP requests, and then your main Lambda will need to send an HTTP request to all other services to wake them up. With asynchronized, you have SNS in the middle, so you will just store your messages there, and they will be sent to all other services, which means that you don't need to know this main service doesn't need to know the IP address or the name or anything of other services. It just needs to know where the SNS is, and the SNS will handle everything else. Since I said that there's a problem with logging on the microservice architecture sometimes, for logging of the serverless functions, I recommend using AWS CloudWatch, since it's a really simple way to integrate your to log everything from your serverless functions. And you will have everything at one place with a nice search. You probably already tried AWS CloudWatch since it's becoming more popular for other apps too. So let's see. You probably want to see some code and see how this magic is really working. And here's an example of a simple function. So this one is just so you just export a function. For example, the name is handler. You get so that's a function with event, context, and callback params. The first one is the event that woke up your service. So if it's something coming from SNS, you will be able to see data there. Context is same thing, so more about your Lambda function that's running. And the callback is used for sending a callback to the back to the service that we requested it. And callbacks is using Node.js structure. So the first thing is error. Second thing is the thing that you want to return. And you can just use callbacks. And this is enough for a simple function. Then you can extend this, create bigger logic there, business logic that you need. And you can also send errors. And then every error that's sent there will immediately go to CloudWatch. Then when you have a function, you need to go to AWS, find Lambda service, then create a new Lambda function, and you will see something like this. So this is a new UI. It was worse. And it's kind of complicated. Since you have your function, you can connect it to the API gateway, Amazon CloudWatch. You will need to do the manual work for every Lambda function that you create. And you need to configure those things there. And also, you will get a simple editor for your Lambda functions. And for every function, you will need to go there and to manually paste the code, which can be complicated sometimes. And that's why some nice people created tools to help us build serverless functions and to easily deploy them. So the first thing, it's really simple. It's called Claudia.js, and a couple of my friends from Serbia, from Belgrade, created this since they had the same problem with manually copy and pasting the code. And you can find Claudia.js on claudiajs.com. It's a simple tool. It's a small library. You will just have a command line app that will allow you to easily set up any Lambda function. It will connect to your AWS account and set up it there. You can delete it, you can update it, you can send a new code. And it's simple as this. So you will just install a global Claudia app. You will use Claudia create to create a new one. And the handler is the name of your function and the file that you want to use where the code is living. With Claudia Update, when you make some change, just run Claudia Update. You don't need to go to the UI and manually copy-paste and update the code. And if you want to test it, so you want to ping the service to see if it works, you can use Claudia Test Lambda. And also you can pass some JSON object as an event to see if your service is really reacting as it should when you send some data. They made also Claudia API Builder library, which allows you to have something like so the same code as Express.js has. So it's easier for you to migrate to serverless, to migrate your services there. So API Builder is just the living in Claudia API Builder npm module. And you will get so api.get.post, delete, and so on. You can create your endpoints and have some code inside there that will handle those requests. And then when you run Claudia Create, it will run the API gateway. It will run the Lambda function for you, so you don't need to make those connections and those charts that we saw. And you will also get the API endpoint that you can immediately use. The Claudia.js, as I said, is a really simple tool, but something more advanced. It's called the Serverless framework. So it's a bit mature it's older than Claudia.js. You can find it on serverless.com. And it also works with Node.js, but with other languages too that are supported by service providers. And serverless framework is also giving you some command line stuff. You can install it, create, deploy. Same thing as Claudia JS has, but it has one more advanced thing. It's this YAML file where you can specify all your Lambda functions, but also you can specify if you need a Dynamo, for example, a database, any kind of it on your service provider. You can, so you see line 6 is the provider name, so AWS. If you change that to Google Cloud Services, it will probably work without any changes, and it will allow you to just deploy and migrate your code to any other service provider, since you will just have your whole infrastructure in this one file. And in this file, you will also be able to run SNS to connect your Lambdas to SNS and do the whole setup just by writing your code. And then we're doing serverless deploy. The whole infrastructure will be there. So we are almost done. So today, who's using serverless? As I said, a lot of companies are trying to build stuff with the serverless, since it will cost effective. It gives you ability to abstract all logic inside just by writing files and creating the business logic there without some hassle around infrastructure. And so conclusion, what we were speaking about today, serverless is not just a buzzword, it's a really cool thing. It will be bigger and bigger as it evolves. A lot of conferences are just oriented to a serverless development. And a lot of apps, like some stuff for logging, for monitoring your services, are coming up. So we are getting more tools and more support there. So please try it. You have freedom to pick providers and tools that you want. There's free auto-scaling, so it's really amazing. And you will have your infrastructure as a code. And you will have fast development, deployment, and delivery. And believe me, it will be really fast. You will be able to complete more than you are doing now with some regular microservice architecture. And that was everything. Thank you.
Thank you, Ivan.